Introduction to Algorithms course. Topic sorting algorithms. Bubble sort idea. If we look at the element in the sorted array, the largest element is at the n minus n index. Second largest is at n minus 2 as index, and so on. So a basic idea would be to first traverse the array from 0 to n minus 1 and place the largest element at the n minus nth index. Again, traverse the array from 0 to n minus 2 and place the second largest element at the n minus nth index, and so on. After the end of first iteration, the largest element in the array bubbles up towards the n minus 1's index. Similarly, after the second iteration, the second largest element in the array bubbles up towards the second n minus n minus 2 index, and so on. In general, at its iteration, we place its maximum element at n minus I index. This process will go on till the whole array is sorted. Bubble sort steps. We can run two nested loops. At each stage of the outer loop, we aim to place one input value in its correct position in the sorted output, so we run the outer loop n times from I equals 0 to n minus 1. After the first k iteration of the outer loop, all k maximum elements have been placed from an index n minus k to n minus 1. So at the k plus 1th iteration of the outer loop, where I equal to k, we need to place k plus 1th maximum element at n minus k minus 1th index. So we need to run an inner loop from nk1 or n minus I minus 1 time. Or in simple words, inner loop will run from j equal to 0 to I minus 1 n minus I minus 2. Now the critical question is, what would be the logic inside the inner loop? The idea would be simple. Starting from the first index, continuously compare adjacent pairs of elements from left, j equal to 0 to right, j equal to n minus I minus 2 if they exist in the wrong order, then swap their positions. In such a way, larger elements bubble up to the right next index, ni1. Here's the bubble sort visualization. Here's another visualization. Data was plotted in a coordinate system with each point x or y is indicating the value is sorted at index x. Then the data would be sorted by bubble sort according to every pixel's value. Here's the bubble sort pseudocode. Selection sort algorithm. The idea of this algorithm is simple. We scan the whole array to find the smallest element. Once we find it, we swap the smallest element with the first element of the array. Then we'll look for the smallest element in the remaining array without the first element and swap it with the second element. This process goes on till the whole array gets sorted. In general, at any ith step of the algorithm, it maintains two subarrays in a given array. First, subarray x from 0 I minus 1, which is already sorted. The remaining subarray x from I n minus 1 is unsorted. We build the partial solution or sorted array incrementally by finding the mean value from the unsorted part and adding it to the sorted part. In every step of the iteration, our sorted part size will grow by 1 and the unsorted part size will decrease by 1. Now the critical question is, how do we implement the above idea? Let's think. Selection sort steps. We need two nested loops, an outer loop to place all n elements in the sorted order, and for every ith iteration of the outer loop, we run an inner loop to find the smallest element in the remaining array. So we run outer loop from I to equal 0 to n minus 2 and repeat the following steps until the array is sorted. We also initialize the variable min index to store the minimum value index of the unsorted part. Now for every index I, we run an inner loop from j equal I to n minus 1 and find the index of the minimum value in the unsorted part. And here now, place the minimum value at ith index by swapping the value at I with the value at min index. So swap x min index xi. Here's the selection sort visualization. We find sort and we replace the second with the number 3, third with the number 4, fifth, fourth with the number 5, then 15, 26, 19, and 19 will be swept. 26 and 26 will be swept. 27 and 27 will be swept, and etc. Here's the selection sort pseudocode. And insertion sort algorithm. It works the way you sort a hand of playing cards. We start with an empty left hand and all the remaining cards down to the table. Then we remove one card, so key, at a time from the table, unsorted array, and insert it into the correct position in the left hand sorted array. To find the correct position for the card, we compare it with each of the cards already in the hand, from right to left. Now the core idea is if the first few elements of an array are sorted, we can easily insert an element at the proper place in the sorted part at any ith step of the algorithm. It maintains two subarrays in a given array. First subarray x from 0 I minus 1, which is already sorted. The remaining subarray x from I till n minus 1 is unsorted. Here's the insertion sort steps. We run a loop from I equal to 1 to n minus 1 and repeat the following steps until the whole array is sorted. We are starting from I equal to 1 because I equal to 0 is a case of a single element that is already sorted. We initialize a variable key with x I. We will place this value in the correct position of the partially sorted array x 0 I minus 1. For every index I, we run an inner while loop from j equal to I minus 1 to 0 and find the correct index to insert the value key in the partially sorted array x from 0 I minus 1. For this, we move elements of x of 0 I minus 1 that are greater than the key to the position ahead of their current position to make space to insert the value key. And after the inner while loop, j plus 1 will be the correct position of the key in the partially sorted array. Insert key at j plus 1's index x plus x of j plus 1 equal to k. Now move to the next element by incrementing the value of I. After the completion of the outer loop, array x of contains the sorted output. And here's the insertion sort pseudocode. Thank you.